Thank you for this very cool introduction. Okay, my presentation is called Layer Cake, and this is a project that we started with my colleagues in CERT 1.5 months ago. It is an experiment, so we decided to build a hunting malware lab with emphasis on sharing the IOCs, IOCs being the indicators of compromise. So yeah, layer cake, hunting malware, and sharing IOCs like a boss. So it's an attempt to go beyond traditional ideas and scale the capabilities of tools that you might know already of. So as you saw in the first slide, this has been done not only by me, but also by my colleague Uldis Koškins, nickname Bro. We both work at CERT.LV. I'm heading the technical incident analysis group at CERT.LV. And layer cake, as you can see, it has a lot of different layers there, and the layers represent those tools I'm going to be describing during my presentation. And also I'll share some experience that we have during those experiments. We encountered also some pros and cons of these solutions. Some of them are better, some of them are not that good, also from the scalability perspective, and I'll share that with you as well. So the recipe, we wanted it to be an open source. So open source ideas, we would like to see some visual component there as well. So event monitoring and analysis capability would be nice. And going beyond the traditional ideas capabilities, malware hunting, automated malware hunting and analysis in the sandbox environment is something that we would like to achieve as well. And with emphasis on IOC sharing. So there's a problem, some kind of a problem with IOC sharing among the security experts, but I will describe that in detail a little bit later. And why I think that, at least for commercial malware, sharing the IOCs is an absolute must, and there's nothing to hide there. So, yeah, scalability. As you see, there's a Raspberry on top, and the reason is just for proof of concept, but I'll explain why we choose it. So it's not just a berry. It's a technical solution. And of course, low budget is for the first experiment is also a crucial part. So for the sensor equipment, we choose to use Raspberry Pi 3 Model B, which you can see here. So basically, it's a small Raspberry Pi computer with one network interface with USB interfaces that you can utilize also for network if needed. 4 cores, and this is something really good to have those cores if you use software for IDS that is able to thread. So like most of you, I guess, would know Snort IDS. Snort IDS was not used in this experiment just because it's not able to utilize several cores at a time. So the recipe goes that those tools on top, as you can see, is Bro IDS, which is basically the main player on the lower level. The Bro IDS also could be, you could add Suricata IDS, for example, in combination with Bro IDS. And I'm again mentioning Suricata, not Snort, because Suricata is the one that is able to utilize several cores of the CPU, and Snort has a problem with that, even in the latest version. rsyslog. This component is used to collect, aggregate, and dispatch the format and dispatch the logs to the central repository for storing and analysis. So maybe some of you have heard of ELK stack, which is Elasticsearch, Logstash, and Kibana. So here we used something called ERK stack, which is Elasticsearch, rsyslog, and Kibana, just because Logstash is not efficient. And to do an experiment with IDS on Raspberry Pi I think it's really a good motivator to learn to use those resources, technical resources of the device more efficiently. So Elasticsearch and Kibana, it is also those components are also sitting on the Raspberry Pi, and Jara is a tool that I will be describing in more detail a little bit later. So what I'm trying to say in this slide, that you can have fully functional IDS at your own network for about 45 euros, and it will be capable to analyze the traffic approximately on 30 to 40 megabits per second. At least this is what we were able to achieve in our lab environment. If you would like to go further and expand this to have a more complete solution like we decided to do with the layer cake, so to build a malware analysis lab and automate the stuff with emphasis on IOC gathering, correlation, and sharing, you would probably have to go outside the boundaries of Raspberry Pi. And this can be started with as much as 300 euros. So basically in your Soho environment, you could start with more or less reasonable workstation, and it will work there. So for malware analysis, it's a sandbox environment called Cuckoo, and for IOC sharing, it's a tool called MISP, which is short for Malware Information Sharing Platform, and it is developed. It is a community effort developed in European CERTs, started by NATO and CERT, and then the development has been took over from Luxembourgish CERT. So why not using sugar, spice, and everything nice for the layer cake, right? And here are some thoughts and explanation on why we have chosen those things. As I mentioned, Raspberry Pi is affordable. It's small form factor. It is suitable for a proof of concept and actually for real life Soho, so small office, home office applications as well. So if you're a security enthusiast or maybe security professional and you don't have your own malware analysis lab, and maybe you have it but you would like to automate things, then this is something where you could start off and start small and go big, actually. So yeah, well, the thoughts that we had in mind when we had a draft of this project is that it should be able to move beyond Raspberry Pi, and this is not a problem. As I mentioned, it's just a proof of concept on Raspberry Pi, but it can be powerful servers or cluster of servers if needed. It can be beefed up and pumped with steroids, basically. So you can have your sensor network, which is one cluster, and then you can have your analysis part, which is Elasticsearch clusters, and have your environment centralized, that you have a lot of Elasticsearch nodes and one node that is querying the others for analysis, for central analysis. have a visual components like Kibana and other graphic tools. So the Bro IDS has been chosen just because we had an experience before with Suricata, and you can do quite a lot of things in Suricata as well. Pretty much the same like in Bro, but there are also quite significant differences. For example, the main would be that Suricata is based on a signature matching ideology, and the Bro, on the other hand, it does not rely on specific signatures, though they can be implemented. Bro, the biggest power of Bro IDS is that it's its own scripting language, where you can actually define what you think might be suspicious on your network or suspicious behavior sets, and what to do with it when those specific conditions occur. So basically, the Bro IDS it is effective, and it can be used also in the large-scale networks. So this particular example with 100 gig network experiment has not been done by us, but it has been done in universities in the United States. And another good thing to consider when you're choosing the IDS for a long term is to understand if it's an open source solution. Does it have some funding? Who supports it, etc. So I think it's a good point to know that basically U.S. government is supporting development of Bro through science foundations. So I will quote a guy from Tau Security by telling that Bro is not about trying to tell you what's bad on your network. It tries to tell you what's happening. So at some point, for some people, it might look not the solution that is needed, because you have to think for yourself, and there is no out-of-the-box setup for Bro that you can implement like a black magic box and forget about that. So this might be a downside for some people, that you have to involve. Yeah, this is what happens with open source. You have to maintain it yourself. But also there are quite interesting projects for Bro IDS, and one that I should probably mention is Critical Stack. And you can go online and see intelcriticalstack.com. They have a really nicely integrated solution that you can subscribe to. The problem is that the client part is closed source, and they say that they're not collecting any data, but who knows? Okay, but still, it is really straightforward to use. You can subscribe to their services. You have a nice dashboard for getting the feeds. You can customize your own feeds. You can get it from outside sources, and everything runs smoothly. Worth checking out. So as I mentioned, our syslog is used for log dispatching and sending it to Elasticsearch. Elasticsearch and Kibana for data and data visualization, data searching and visualization. And Jara is something that is used on both sides, on Raspberry to make those decisions and create signatures, and on Cuckoo Box as well. Well, one example might be that you can define in Jara that I'm interested in Microsoft Office documents that contain macro code, and if it contains macro, then I would mark it as suspicious and push it down for the further analysis. And this is actually what's being done also here, and I'll have a demo a little bit later that works. So you can have nice graphs and visual tools with ability to dig down deeper and see those technical details as well. Perform some basic analysis on what's happening in your network. You can have bro ideas out of the box and being able to have your NetFlow data, have your historical information on what's happening, have a passive DNS solution. So for those who are not familiar with passive DNS technology, it's an idea of DNS journal. Like NetFlow is your journal for network communications in general. Passive DNS is a journal for DNS queries and answers being presented. And underneath all of that, the log information is in JSON. So probably it's not that comfortable to read or to comprehend for human beings. This kind of information, much better look is here, right? So this is why some visual components are involved through Kibana. And this is an example of passive DNS journal, also straight from the Raspberry Pi running Bro. This one example is with CERT.LV domain, and here you can see that from the passive DNS information, you can see that on July 14th, we had our domain pointing to IP address located in Institute of Mathematics and Computer Science, University of Latvia, and on the July of 15, 2016, it has changed. So I'm bringing up this example also because we have seen a lot of cases where people are migrating to DDoS protection solutions. They change their DNS during this migration. So basically, it's like a CDN solution on Cloudflare, if you're familiar with that. But the thing is that they are still running their web on the old IP address just as it was before, but the DNS is pointing to DDoS protected environment. And if the attacker knows the previous IP address from the passive DNS information and the main web server is still there, just protected by the proxy, you might call it, DDoS protection environment, he can attack the previous IP address directly. So this is what you can find also in passive DNS. Okay, so the Cuckoo environment is highly customizable. This is why we choose it. There are several other environments, and also with a thought on mobile threats, Cuckoo has a branch for Android sandboxing. So this is something that we are researching currently as well. And a nice tool is integration with the MISP platform, that you can straight away push your indicators of compromise from Cuckoo sandboxed analysis to malware information sharing platform. And this is what I mentioned during the beginning of my presentation. There's hardly any reason I can imagine for keeping the commercial malware indicators of compromise private. So I can understand those cases with APT that people would like to keep it quiet and perform some analysis, and maybe at some point they would be willing to share some of that. But with commercial stuff, it's not the case, and we should share more efficiently, and those tools, they are able to help us to do so. So criminals are sharing the information much more efficiently than we do currently, and on the good or on the bright side, and this should be changed, and those tools I'm presenting can help us to do that. Yeah, and keep this information on IOCs more structured and available, so it doesn't go black hole like it usually does if we have just a sandbox solution. So here's a demo. What I'm demonstrating now is this particular solution where you just accessed a bad SSL, there will be 3 kinds of SSL: self-signed certificate, and the reason why I'm demonstrating is that criminals are usually using illegitimate SSLs during their campaigns. Though SSL is quite cheap to buy, and some of those projects are free of charge, still you have to highlight yourself. So as you can see, during the clicking on those bad SSL sites, almost immediately you can see on the dashboard that event comes up, and the operator or people that are analyzing the stuff on your network can do some digging with just several clicks. You can see the host which has been accessed because of the illegitimate SSL. The alert is there just because it's something bad with SSL. If it would be okay, like visiting a bank, it would be not there. And here's an experiment with sending an email. So the IDS is sitting there, the automated sample analysis is there. Jara is engaged when it sees that here I'm sending the Excel file. An Excel file contains macro with Loki, the ransomware, crypto ransomware. Here we can see the event popped up in the analysis dashboard. We can go and have a look at what is happening there. So we can see that this local host, we can see who sent the malicious email, some details like subject and stuff. We can see network parameters like IP address and ports. We can see the link. This particular link is a link to analysis, so the sandbox environment. So we can go to the Cuckoo sandbox, and this whole thing happened auto-magically because of the environment, the layer cake we have built. And in a Cuckoo environment, you can already see that the sample, the Excel file, has been analyzed. There are some indicators of compromise on the network side, so you can immediately grab those out of this log and share or search for indicators of compromise on your network, and etc. So, of course, there are pros and cons, and con in this situation is that in this case, if the end user receiving the email would open the Excel file, if no other solutions would protect them, then he would be infected. And we would know that in this solution post factum that, yeah, well, it went through, we have analysis, we have full spectrum of IOCs, but still it's not on the active protection mode. But you can fix that by just configuring it accordingly. And with Bro IDS, you can do in those Bro scripting, in the Bro scripting language, you can actually do a lot of stuff that is not relevant to IDS or your Bro environment. You can call out to, I don't know, create an ACL on Cisco because you saw a particular event, or do some different stuff, or shut down the port, for example, or do whatever you like through those scripts. Another thing that people usually do with Bro is they integrate it with Varis Total, but if you have Cuckoo, it's already done there. So this, what you can see is MISP, which is that malware information sharing platform, and the information that you can see here is also now was automatically submitted from Cuckoo Sandbox to MISP, and here you're able to see all those indicators like you saw in Cuckoo, but the difference is that you can have a searchable historical journal of IOCs, and with possibility of correlation. Like here you can see those red numbers. Those are numbers of other events being submitted to malware information sharing platform that have similar indicators. So For example, if there would be a domain xx.lv involved in malware campaign, then and you would have 10 samples with that, you would see the correlation that it's there, or DLLs or registries or whatever else you can grab out of the IOC package. You can see the correlation there, which is good for broader analysis during the time of campaigns, that if you are able to observe them. Yeah, well, and the idea of MISP, the Malware Information Sharing Platform, is that you can have those indicators for yourself, but the main goal is to be able to share with your trusted partners those indicators, and you can actually link several instances of MISP for synchronization. You can create groups of users like all communities, or you can create, for example, limited community with, for example, we have a financial institutions, and if I create an event tagged that is dispatched, it can be dispatched only to financial institution group, that only they will see the information. And if I create an event defining that it is meant for all communities, then everyone will receive the information. And yeah, this is, I think, really good. So there are several takeaways. So CERT.LV Sandbox will be available publicly in the second quarter of 2017, so anyone can use it. Raspberry Pi image is not available publicly currently, but if you're interested in the project, then as its experiment, we can share it. CERT.LV Malware Information Sharing Platform is available for all the participants of CERT.LV sensor network, and basically it means government, but any other trusted partners or researchers or other enthusiasts are also welcome to contribute, and you can get an access to MISP by just contacting us and explaining the use case and motivation for that. And there will be a network forensics and monitoring course held by CERT at third quarter of 2017. So to end my presentation, I just want to say that you can have your own fully functional IDS that is scalable for less than 50 euros. If you're interested to go beyond that and analyze malware automatically and have those IOCs and MISP integration, then they probably have to buy at least a workstation, and altogether you can start with 400 euros and you have your malware hunting lab with IOC sharing platform. So I would encourage all of you to participate in making the internet a safer place, and if you're interested in a project, feel free to contact me or CERT team at CERT.LV. Thank you. And if you have any questions, and if we have time.
We have time for one question. Okay, then this will come from me. Is it possible to use this system, this layer cake, for the tech-savvy and probably security-savvy home user person type?
So, yeah, well, this is something that I think the general user might not be able to implement at his home, but tech-savvy definitely, and it's not that hard. There are a bunch of tutorials online already how you can do that. As I mentioned, if you're really interested in the Raspberry Pi approach, we can provide an image as well at some point. So definitely, you can start with small investment and have big results.
Okay, thank you.